synchronous counter is constructed based on several JK flip-flop. So the purpose of synchronous counter is to produce special purpose in order to count a sequences. So the sequences may be not in order. Okay. Example here we have 0, 2, 4, 6. And then under the synchronous counter, you need to know on how to derive the excitation table. So under the excitation table, we have present state and we have next state. So present state and next state is referred to the input value, and then we have JK. As I mentioned, that this synchronous counter is constructed or made from multiple JK flip-flop, so it has a JK flip-flop as the output part. Okay, so present state is the current state, and then next state is the next state. From the current part goes to which state. Okay, so let's say we have present state 0, next state is 0, so J will be 0, K will be X. As we learned in the chapter 4, Karnaugh map, X is referred to the don't-K term. So it can be either 1 or 0. Okay, and then if the present state is 0, next state is 1, so J equal to 1, K equal to X. Present state is 1, next state is 0, J equal to X, K equal to 1. Present state 1, next state 1, JK refer to X0. So this is the mode for the JK flip-flop. Okay, if mode 0, 0, if the condition is 0, 0, J and K is 0, 0, so the mode will be whole. If J equal to 0, X equal to 1, so that's mean reset. Okay, we can have two possibility, 0, 0 and 0, 1, because we have 0x. X can be 1 and X can be 0. Okay, the next part we have toggle and set. At this point, if present is 0, next state is 1. So if 1, 1, so toggle. If 1, 0, so set. Okay, the mode is set. Okay, the next value, present state 1, next state 0. So if 1, 1, toggle. If 0, 1, mode is reset. Okay, next, when present and next is equal to 1, so it can be either whole mode or set mode. If 0, 0, whole, if 1, 0, set. So the process is like this one. Okay, let's say the current one is at 0 state, this one is 0 state, this one is 1 state, state 1, state 0. Okay, let's say the value is 0, 0. Okay, 0, 0, so it will hold. Hold mean it will hold the previous one, so 0 goes to 0. If X equal to 1, so it will reset. Okay, so reset will be 0. Mode reset 0, 0, 0, 1, it will be reset 0. Okay, next, let's say we have from 0 state to state 1. So the possibility 1x. If x equal to 0, so that means set. So in set mode, we goes to 1. Q equal to 1. If you still remember the previous chapter under the flip-flop, if set, so 1, 0. Okay. And then if x equal to 1, so we will toggle. So the current state is 0. When we toggle, so from 0 it goes to 1. Okay, the same goes for this part. Okay, let's say we have x0 if the position at 1 and 1. So if x equal to 0, so that means hold the value. If x equal to 1, that means we set the value. Okay, and then lastly here, from state 1 to 0. Okay, from state 1 to 0, if x equal to 0, so that means 0, 1. So 0, 1 is reset. So if the current state is 1, it will goes to state 0. Okay, next, if x equal to 1, so that's mean 1, 1. So 1, 1 is toggle. If the current state is 1, so toggle it will goes to 0. So the mode is identified, or the value of j and k is identified based on this condition. So the present state and the next state will identify or will determine the value of j and k, either 0x, 1x, x1 or x0. So let's look to this example. Okay, based on this example, design a synchronous counter to count the following sequence: 0, 1, 2, 3, and then 0 again. Okay, so the first step, you need to draw the transition diagram. Okay, this one is the transition diagram. So your transition diagram must be based on this number. So you have 0, you have 1, you have 2, you have 3. So based on this sequence, that's mean from 0, it goes to 1. So the direction, you must draw the direction of the state. From state 0 goes to state 1. From state 1 goes to state 2. From state 2 goes to state 3. And then from state 3 goes to state 0 back, or 0 again. Okay, after you draw the transition diagram, you need to derive the excitation table. So in your excitation table, you must have present state and you must have next state, and the output will be your JK flip-flop. Based on this sequence, you know that the number is 4. You have 4 states. In order to get 4 stats, okay, 2 power of 2. So that's mean you need 2 JK flip-flop. Okay, when you need JK flip-flop, so you can have JKA and JKB. Okay, so your present state, you must have present state A and B, next state A and B. And then at your JK column, you must have JA, KA, JB, KB. Okay, now you need to fill in your present state and your next state based on the transition diagram here. Okay, let's say the first one we have 0, so you put 0. After 0, 1. After 1, 2. After 2, 3. Okay, this one is the present state. So A and B hold the value of binary. This one is 0, so 0, 0. This one is 1, so 0, 1. And then you have 2, 1, 0. 3, 1, 1. Okay, at this part is the number in binary. This one is in decimal. This one you just translate into the binary number. Okay, next, fill up the next state. So next state, this one present 0, 0 goes to number 1. Number 1 goes to number 2. Number 2 goes to number 3. And then number 3 goes to 0. So from this decimal, you need to translate into the binary. So 1, 0, 1, 2, 1, 0, 3, 1, 1, and 0, 0, 0. Okay, the next part, you need to identify this value, the JK value, JA, KA, JB, and KB. So how to identify the value is based on your present state and your next state, based on this diagram. Okay, first we look for JA. Okay, JKA. We look for JKA first. Okay, this one, the present state is 0. The next state is 0. So based on this diagram, 0 to 0, so 0x. So you put 0x. Next, 0, then it goes to number 1. So zeros goes to number 1. So that means you have 1x. So you put 1x. Next, A, you have 1. A prime, you have 1. So that means 1 to 1. So 1 to 1, that means you put 0x. Sorry, x0. x0. Okay, next, E is 1, A prime is 0. So 1 to 0. 1 to 0, you put x1. x1 here. Okay, done for your JA and KA. Next, identify what is the value in JB and KB. So the value in JB and KB is based on B and B prime. So current state is 0, next state is 1, 0, 1. So 0, 1 here, from 0 to 1, 1x. You put 1x. Okay, next you have 1, the next is 0, 1, 0. So 1, 0, you put x1. x1. Okay, next part you have 0, 0 goes to 1. So 0 to 1, 1x. So you put 1x here. And lastly, you have 1 to 0. So 1 to 0, from this 1 to here, from 1 state to 0 state, you put x1. Okay, now you have complete your excitation table. After that, you need to do simplification based on the K-map. So based on your excitation table, okay, you have how many output? 4 output here. So you have JA, KA, JB, and KB. So that means you need to derive 4 K-map table, 1 for JA, 1 for KA, 1 for JB, and another one for KB. So inside your K-map table, you must map all the number 1 and the don't-K term. Okay, so your K-map look like this one. Okay, this one is K-map for JA, K-map for KA, K-map for JB, and K-map for KB. So map all the don't-K term and number 1 output, and then draw the loop in order to simplify the expression. So based on K-map JA, okay, we have 1 here and we have don't-K here. So we can loop the largest one, A, 1 and x. So at this point, okay, it's equal to B. For KA equal to B, for JB equal to 1, for KB equal to 1. So based on this K-map table, you already have 4 expression. So based on this expression, you need to draw the synchronous counter circuit. So the next part, you need to draw the synchronous counter circuit. So you must have, when you draw, it's based on how many JK flip-flop that you have. You have 2, so you must draw 2 JK flip-flop. 1 JKA, another one is JKB. Okay. Then in synchronous counter, the clock pulse for all JK flip-flop are similar. Okay. So the input of clock pulse here, you must draw this one, clock pulse, for every JK flip-flop inside your circuit. And then the input here for JA and KA, okay, based on the expression, JA equal to B, KA equal to B. So this one is JKA, JKB. So Q here is referred to B. So the JA equal to B, so B put as the input for the JA. KA also from B. Next, JB and KB equal to 1. So put JB and KB 1 as the input. So now done for your synchronous counter.